like a calculator, there's a protractor calculator. I'll find out what is use of this. This is the most essential of the total science and technology, the derivative. Let's explore the, I think already we have discussed, no, slope of a tangent drawn at any point. Let me go for y equal to x to power of n. Generalized formula will derive. Then I'll come to the other thing. Now this is the power rule, what we can call it. Y equal to x square, I did not. Let's go for a generalized derivation. Now let the small change in x be delta x, then the corresponding change in y be delta y. Again, let me take y common, 1 plus or minus delta y by y, x to power of n. Y and xn get cancels. Okay, now this already we know. Can you remember binomial theorem? We had a discussion about binomial theorem. So let me explain binomial using binomial theorem. N into 1 factorial delta x by x plus n into n minus 1, 2 factorial delta x by x whole square, n into n minus 1, n minus 2, 3 factorial, and so on. So limit delta x, so let delta x tends to 0. Then delta x square will be very small, will be 0. Even what happened to the cube of that very small quantity should be negligible. What do you mean by this? Delta x tends to 0. How you have to interpret delta x as delta x tends to 0? Means you are saying that delta x will become very small. Okay, let's substitute all the things. So 1 plus or minus delta y by y is equal to 1 plus n into 1 factor is 1 delta x by x. The remaining quantities all will become 0 and 0 as they are negligible. So I'll end up with plus or minus delta y by y, 1 plus or minus n delta x by x. So this will become delta y by delta x plus or minus n into y by x. Limit delta x to 0 plus or minus delta y by delta x. So this will become now n into, what is y? Y will become x to power of n. Keep it here. Now, what is this quantity? Limit delta x to 0. Better write plus or minus here. So what is it? This total quantity, you have made delta x so small that it tends to 0. Then correspondingly, y also will become very small. Then this will become dy by dx. I think this is something very, very important. So how come you are writing delta y by delta x as dy by dx? How come that change you are making? If delta x tends to 0, once again, the graph, a student must have this imagination. This is something very important. At least we have a certain tools here where you can imagine what do you mean by that small. Like this. This is a delta x. Now what happened? I'll decrease delta x. Then it will become dx. No. Once again, I'm trying to explain everything. This is delta x will take it. This is dx. No, this is delta x. No, If delta x tends to 0, if it becomes so small that it will become dx. Thin line, just thin line. Sir, how much of small? So can you say thickness dx 1 centimeter? No, infinitesimal length tends to 0. Some micrometer, nanometer, picometer, 10 to the power of minus 100, 10 to the power of minus 500, 10 to the power of minus 2000. Infinitesimal length it is. Dx is so small that delta x tends to 0. This is delta x. Now I'll decrease the value of delta x, how much it has become so small that it tends to 0. I think even on paper, it is not equal to, not tends to 0. It is having some value of say millimeter, maybe around, I think 1.5 millimeter is there. What you should imagine, very small change in delta x, almost tends to 0. That is dx. Correspondingly, there'll be also change in y. There'll be also change in y. Then what you do, the delta y also will have very small infinitesimal change that is equal to dy. Now, if you draw a triangle here, you are going to get a triangle, very infinitesimal triangle. You'll get an infinitesimal triangle. Where that infinitesimal triangle here, such that this will be delta y, this will be delta dx. The ratio of those two is what now? The slope. Able to understand things. These are very fundamental part of the calculus. So now we know like from the identities, x to the power of n, x to the power of minus 1, exponential, product rule of exponential, n x to the power of n minus 1. So that plus or minus, I'll take it out. Okay, this called like a power rule in differentiation. So provided n should not be equal to, n should be greater than 0. I think, shall we put a condition? N should be greater than 1, we'll write it. Okay, there's a one very power rule is what we can call it. So with the help of this, we can find out the derivative of any of the quantities here. Let's go for the derivative of a constant. I think already we have explained this one, no? Yeah. Now we'll take one more. The derivative of a constant. Derivative of a constant. So there's a horizontal line. I'll produce a small infinitesimal change. I'll bring it, this one. Okay, this is delta x. I'll make delta x so small that delta x tends to 0. What will happen to dy? What will happen to dy? You see this is a delta x. Delta x tends to 0. And it will become very small that delta x tends to 0 and will and this become dx. Is there any corresponding change in y? No, the y is some fixed value, no? Call a. And what is a? A can be 2, 3, 4, any some fixed value where a is a constant. No change in y, no? Then therefore, what is the value of the derivative of a constant? If y equal to a, then dy by dx should be 0. So therefore, the derivative of a constant, what we'll write? Means though x changes, y will not change. That's all, simple. Don't break your head much. You can see that though x varies, y will remain constant. So the derivative of a constant will be 0. No change in y. And how you define slope? dy by dx, dy is 0. So therefore slope is 0. So the derivative of will be a constant here. Okay, no, sir, like let's do one thing. If I have some function like this, 3x squared, or selected y equal to a of f of x. F of x is some function. What is the derivative of this? I'll take it some. Then how to manage this one? That a is a some constant, keep as it is. Then take the derivative of 2x. How much it will become? Dy is equal to a into x to power of 2 minus 1 dx. So this is a value of dy by dx. If you have some function here, there's a constant into some function. Okay, let it be that one. If you have two functions like y is equal to the derivative of f of x plus g of x, then this should become derivative of f of x plus derivative of g of x, or you can call f dash x. After differentiating, put that one, g dash x. F dash means here, what do the dash indicate? Differentiated ones. This is called like a linearity principle. Once again, sir, like we didn't understood this. Y equal to x square. What is the meaning of that? Okay, we have calculated slope, everything. What is the graphical explanation of that? Let me try for the explaining y equal to x square graphical. E is what I just brought something. I wanted to explain graphically. See, some people may not be very good in mathematics, but through graphs or through diagrams, through some pictorial representation, they may find a little bit easier. Okay, I have some square plate. What is the area of that? Length into breadth. Okay, there's a length, there's a breadth. So x into x, x squared, there's the area. Then I'll change the side length by small infinitesimal length here by dx. This is also dx. Are you able to notice this? So what was the change I produced here? Change in area. So here dx into this is x, no? This is x into dx. This much of additional red color strip is being added. I think able to analyze here. I've just incremented the area. I produced some change in area. So let me increase this length by infinitesimal change dx. Let me increase the breadth by infinite change by dx. Getting now. So what is the area of this strip? X into dx. What is the area of this strip? X into dx. And you see this also will come. Some common nugget you can call, or the common infinitesimal elemental area dx into dx here. So what is the change in area? I think I have to add up these two. dA is equal to x dx, x dx, dx into dx. So this will become 2 dx dx square. Okay, fine. Okay, what is the dx? Very, very small, no? Dx almost negligible. So dx square, definitely I'll say equal to 0. So what is the change in area? 2x dx. Then let me write it. dA by dx is equal to 2x. I'm trying to explain the significance of it. Y equal to x square. What does it mean? Now, sir, how you are relating to the explanation? So let y is equal to a1. I'm asking you to think. Then let here we'll write it. Let y equal to a1 initially. So what is a1? A1 was x square, no? So this y equal to x square. Let me differentiate this dy equal to 2x to power of 2 minus 1 dx. So dy by dx, here I am getting this one. Now you tell me. So what is dy here? Okay, one more step. What is that dy here? What it represents? Represents change in area. So what we are able to do now, the change in area depends upon the 2 times of initial length into that infinitesimal change in length what you are going to bring. So then what do you mean by dy by dx? Okay, this is okay. So then what do you mean by dy by dx you are going to write? Change in area per infinitesimal change in area per infinitesimal change in length. That is equal to 2 into x you are writing. I think very useful, very useful quantity. So how you interpret this one? Infinitesimal change in area per infinitesimal change in side length. Able to understand? That is equal to what? 2 times of x. The meaning of this, sir. What is the meaning of this? I think it's very clear. What is a area? dA, infinitesimal change in area. So therefore here, infinitesimal change in area per unit infinitesimal change in side length. What it is equal to 2 times of x. If I ask you to calculate this, just you do one thing, 2 into x you multiply. What is the value of x? If you know it, substitute, you will get that much. That will be the dA by dx. I think at many places, the physics, this was the needed here. The student, y equal to x square. Sir, what is y equal to x square? Okay, I'll plot the curve. Then there, I'll draw a tangent. Then the slope of tangent drawn in y graph is what? Dy by dx. Okay, that is a fine. Or sir, y equal to x square, I'll use power rule. Then dy is equal to 2x or dy by dx equal to 2x. Okay, this is some mathematical way of finding out the derivative, first order derivative. What is the meaning of it? This is what needed. In physics, I think we need this. So then on this is called like a how to use it. So now you have a plate. Okay, what action this square plate? So I think now during if the metal made up of iron or any metal with the temperature, it will expand. No? Then if I want to calculate the change in area per unit rise in temperature, it depends upon this one. Okay, what is the dx? Like it will be if the area depends upon side length. Here we can bring it. So many things are there where due to increase in temperature, the side length will change. Okay, what is the infinitesimal change in area per unit infinitesimal change in length? It depends upon the what is the 2 times of its side length is what it's telling. Very fundamental. The physics, I feel like this is the mathematical, nothing wrong. Mathematics is what we are just how to find out the derivative of this function. Calculating the slope of a tangent drawn in y graph, that is a geometrical method. But this is what we needed. We should think of this. The pink color what I highlighted, no? This is what needed. Needed in physics. What is this? This everything is a mathematical solving. The earlier one, what we did is a coordinate geometry. So what is this? There's everything. What all we did. What all we did, no? So there's everything is a I feel like the physics approach is something which will help us a lot to understand the concepts. Every problem, try to analyze with a real situation. I given there's a square plate. Square plate is what real, no, it's not something imaginary. And the dimensions of square plate do change. The changes we are going to express using differentiation. So now, sir, like, can we use differentiation to express a change in one quantity with respect to any other quantity? Yes, that is the main purpose of why we are studying differentiation. Suppose if I have a container, or say bucket, you can call this is, and I'll open up the tap. I'll open up the tap. And this is the water. And the tap is going to fill up the water. So what this tap supplies 2 liters per second. For every 1 second, it produces 2 liters. Then the capacity of this is 100 liters. Then can we, so what is this 2 liter per second? The rate at which water is entering into the bucket. This one, so then in terms of cubic meter, what you can write, 1000 liters is equal to 1 cubic meter, no? And if I say this area of this tank is, say, like 1 meter. Okay, then this height of this, there's a radius. The height of this, let me put it 50 meter. A very big tank it is, or 20 meter will write it, will be sufficient. The radius are 1 meter. Then find the rate at which height of the level of water in the tank will increase. So this 2 liter is a fixed here. Then pi r square dH by dt. So the dH by dt is the rate at which the level of water in the tank varies with the time. H is the height. You see that one? Whenever a quantity varies with the time or vary with any other thing, you can bring the differentiation. You know R value, substitute here, you'll get the required thing. So dH by dt is how much? Equal to 2 by pi. There's a rate at which the height varies. So whenever a quantity varies with the time, you can find out using that. Later on, we are going to learn in fluid mechanics. Now, don't bother anything. Just I'm telling the fun. If a quantity varies with the time or with portion with any other quantity, you can express the relationship between those quantities by using differentiation. That's the major idea of the physics. Already we discussed, no? The derivative of 2x cube, we'll see what we get from the power rule. Dy equal to 2 into 3 x to the power of 3 minus 1 dx. Then 6x square dx. Now at x equal to 3, I want to find slope at x equal to 3 for this curve. Find slope at x equal to 3. What shall I do? So corresponding to x equal to 3, there I'll draw a tangent. Then I'll measure this angle theta. Then what is the slope? I'll measure theta from protractor. Then I'll write tan of that. I'll get the slope. Slope of curve at x equal to 3. Okay, fine. There's a geometry method, what we know. Can I find out by differentiation? What is dy by dx? Nothing but it's a slope, no? So what shall I write here? This is 6x square. Put x equal to 3. 3 into 3 square, 9, 9, 6 is 54. You do one thing, measure theta, tan theta of that you take it, you'll get the same answer. So when you go for Graphical method, what you should do, first you should assume the values x equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Corresponding values of y, put all, take the dots, join them by a curve. Okay, this is a curve. And after getting the curve, then corresponding to x equal to 3, draw a tangent. This is the tangent. Okay, fine. Then tan theta will get the slope. Or else, there's a derivative, use power rule, find out dy by dx. Put x equal to 3, that you'll get this. I think this will take hardly 2 minutes. This is a graphical method. So now are you getting know why we are bothered about this mathematical tool? Very easy to calculate the slope, no? Graphical method. Or using geometrical instrument. And this is the mathematical as a using mathematical tool. Now, what is the name of that mathematical tool? Differentiation. See the way things are brought for us very beautifully. Only thing is, see, we have to show interest to learn. The primary questions are, what is the use of this? They'll ask you. Everything is useful. No, if you have two functions like already, I think this is a linear property, what we can call y equal to g of x plus f. The derivative of that. I'll differentiate this, then I'll differentiate this, I'll add up. This is called like a linear property. So there's the equation. What is the question asked? Find the slope of curve at x equal to 3. So here we will proceed in this way. dy is equal to 2 into dx 3 into 2x to power of 2 minus 1 dx. So this will become 6x dx. So what is the value of dy? Equal to 2 plus 6x. At x equal to 3. Slope at x equal to 3. What shall I write? 2 into 3. You put it 2 plus 6 into 3. This will be 18, 20. Or else draw a curve. Okay, then corresponding to x equal to 3, draw a tangent. Then measure theta. Tan theta, you'll get a slope. Which one you suggest? Definitely, I say that somehow, sir, let me learn this. It will save a lot of time. No? Plotting this graph, drawing a tangent, theta, then tan theta. This is the better method. Got the idea, no? That's the beauty of this derivatives. Let's come for the y equal to e to power of x. This is something I am very much interested to explain it very neatly. We will try to learn it in very simplified way. We'll see what do we'll end up. So this, I think, equation y equal to e to power of x. This is some exponential, no?